Dear students, welcome to our class on weather forecasting for agriculture 14.1.4. In this class, we are going to discuss and understand on fog, F-O-G, fog. This bit will come in JRF, SRF net. The first bit is low cloud. Fog is dash, low cloud. Fog is one of the forms of condensation. As you know, there is a lot of difference between the forms of precipitation, forms of condensation. Forms of precipitation are liquid forms, rain, drizzle, shower. Solid forms, snow, hail. Mixed forms, sleet, glaze. So they are the precipitation from the clouds. Whatever the precipitated part is there, it touches the ground. Here, the fog is a form of condensation. Condensation is a energy releasing process. So dew, fog, smog, rain, like this, there are different types of condensation. So fog, why we are discussing fog? Okay, weather forecasting for agriculture. Yes, fog has a lot of significance with reference to growing of crops, animals, orchard and plantation crops, fisheries, whatnot, forestry. So, fog. See, by definition, as I said 1 minute back, fog is one of the forms of condensation. Fog is also known as low cloud. So, what is the cloud? Cloud, by definition, cloud is defined as minute droplets of water suspended in the air at a higher altitude. At a higher altitude, we call it as the cloud. When it is touching the ground, we call it as the fog. See, this is what. Another most important thing is fog is always treated in terms of visibility. Fog is always treated in terms of visibility. What is meant by visibility? To how much of a distance human eye can see. That is an important aspect with reference to fog. As far as agriculture is concerned, how it impacts, as the class goes on, we try to understand. Now, fog, actually, before I go for actual formation of what is the physics of formation, development and decay of fog, let us see the definition. As I said, fog is a low cloud. What is a cloud? As I said 1 minute before, cloud is the minute droplets of water suspended in the air at higher altitudes. So, same. Minute droplets of water suspended in the air near the ground. We call it as the fog. However, from the meteorological point of view, from the agricultural meteorological point of view, the definition of fog is an obscurity. As I said 1 minute back, half minute back also. Fog is seen in terms of visibility. So an obscurity. Fog is an obscurity in the surface layers of the atmosphere, which is caused by the suspension of water droplets. In the cloud definition also, I told minute droplets of water suspended in the air at higher altitude. So droplets of water suspended in the air near the ground. Now, by definition, again I repeat, the obscurity in the surface layers of the atmosphere, which is caused by suspension of water droplets. Here, the humidity should be more than 75% minimum, with or without smoke particles containing various types of pollutants and associated with visibility. Less than 1 kilometer or 1000 meters. This is the definition. Once again, for your academic interest, from the meteorological point of view, accepted across the globe, definition is an obscurity in the surface layers of the atmosphere which is caused by suspension of water droplet with or without smoke pollutants containing various types of pollutants and associated with visibility less than 1 kilometer or 1000 meters. This is the definition. Now, so what is the physics of formation of fog? There are basically 6 ways in which fog forms. Before I explain on the board, just to try to understand. See, fog formation depends on two important factors: meteorological factors and topography. Number two, the physics of fog starts like this. On a very calm and cloudless day, if moisture in the lower part of the troposphere is more than 75%, then the surface of the earth cools. We also call it as the moistening. Radiational cooling or radiational moistening. That's what we call it as the in the meteorological term, radiational cooling or moistening. That means when the surface cools down, just above the surface, how much moisture should be there? It should be minimum 75% and above. That much moisture is there in the atmosphere. Then, because of the radiational cooling, what is meant by radiational cooling? During the daytime, soil acts as the sink of solar radiation. After the sunset, soil acts as the source of solar radiation. Solar radiation means, no sun is there. From here, you go on, energy goes on living in the long wavelengths. Now, when the surface cools because of radiation cooling in the absence of the sun, that means the soil acts as the source of energy, it loses. So, the ground becomes cool. Moisture in the atmosphere is more than 75. Then that moisture slowly condenses. That's why fog is one of the forms of condensation. So, condenses into fog. That's what we call it the radiational fog or ground fog. This bit will come. This I will explain to you here. Here you see, this is the ground. Okay, energy is going out. So, radiation cooling. Second thing is warm air advection. Third one is the cold air advection. What is meant by warm air advection? 15 degrees centigrade, 20 for example, 20 degrees centigrade of warm air is there on the land. When it passes over a oceanic area or a very big large area, of say a river. First condition is approximately between 20 and 30 degrees centigrade warm air. Okay. When it passes over a relatively cold water body like a ocean or a river or a very big lake, then what happens? There the temperature is 15 to 20 for the air. Here the air temperature over the cold body is 5 degrees centigrade. So warm air is advected, wind, okay, advected. Then cloud form. Exactly reverse. Cold air advection from the land, minus 15 degrees centigrade air is there. The water body is 5 degrees centigrade, for example, say between 6 or 7 or 8 in the evening. Water is 5 degrees centigrade, air is on the land is minus 15. So, cold air advection. That time also we will find, fog is formed. Warm air advection. Cold air advection. This is, the fourth one is the sea breezes. Or sea and land breezes circulation. Sea and land breeze circulation. What is a sea breeze? Sea breezes occur during the daytime. Land breezes occur during the late in the evening or in the night time. Now, when these circulations are interacting, land and sea breezes are interacting, then fog formation is possible. Now, the third one is the upslope terrain. Now, what is meant by upslope terrain? See, when moisture laden air hits the mountains, that is orographic structures, on the leeward side rain occurs. Similarly, moisture laden air, when surface of the mountains is cool and then it hits and goes up, it loses the energy. Okay, condensation is the energy giving process. So, fog is formed over the mountainous areas. That's what we call the upslope terrain. The last one is the boundary layer saturation. Rain had occurred in a high altitude area. Rain occurred. Moisture, relative humidity in the atmosphere is 90%. So naturally the fog forms because rain occurred. Ground is very cold. Moisture 90 and above percent. So what will happen? Naturally the water vapor gets saturated. So these are the basic physics of cloud, fog formation. Cloud and fog formation are almost same, but cloud is at higher altitude, fog is at the ground. This is what I would like to discuss with you. Then we go slowly to what is the life cycle of fog, just like the genesis, the development and the decay. So now what is the see, this bit will come, please note. North Indian plains are most prone to fog. Okay, most of the fog occurs in the North Indian plains. This is then northeastern India. Now, see first the formative phase of the fog. How it forms? What all I explained? Just again, once again, I would like to explain to you the occurrence, development, and dissipation. The occurrence, development, and dissipation of a fog over a region or a place depends upon prevailing meteorological conditions, atmospheric particulate matter such as pollutants, and topographical area. Meteorological conditions, topographical conditions I told. Now atmospheric pollutants also play an important role in the formative phase. The complete process passes through multiple processes. The complete process of formation of the fog passes through multiple processes. What are the thermodynamic, dynamic, microphysical, whatnot, several facts. The formation results from condensation of water vapor into the liquid. Condensation of water, this is the third time I am telling you. Fog is one of the forms of condensation. So the formation results from condensation of water vapor into liquid droplets near the surface as a result of cooling or moisturing. This is what? Cooling or moisturing. Radiation cooling or moisturing. Now, see, fog formation over land involves nocturnal radiative cooling. Nocturnal means during the absence of the sun. Okay, radiative cooling under light windy conditions or no windy conditions or no cloudy conditions. This is the thing. Now, the maintenance phase. The maintenance phase is like the formation is like this. 6 process of formation. Then, what is the maintenance phase? The significant fog layer maintains. Okay, if you take a significant fog layer, it maintains a relatively constant depth, not inches, at least few feet or few meters. It should maintain a depth. So it is a formative phase. You should have enough depth. Okay. Second thing is this phase is characterized by a balance between the opposing forces. What are the opposing forces? It is characterized by 2 opposing forces. Fog formation, fog dissipation. Fog formation, fog. So these opposing forces. Okay, some conditions say, okay, you dissipate. Some conditions you form. These are the opposing forces. That's why I told. Thermodynamic, dynamic, microphysical processes play an important role in addition to radiative processes. Please note the radiative process. Now, the last point as far as maintenance is concerned, these forces act on the top of the fog layer. Okay, which forces? Opposing forces predominantly play because there are droplets of water in the upper part of the fog. This is the problem with the fog. How to distinguish between fog and cloud? Through remote sensing or through satellites or through any process. This is the problem. Water droplets in the fog are in the upper side. This is the problem. Once water droplets are what we think it's a cloud. But actually it is a fog. So there are of course RGB technique, red, green, blue. Okay, differentiating techniques are there in our Indian satellites. We are discussing. But for your academic interest, finally dissipation phase. How the fog dissipates? So once the sun's rays falls on the ground gets heated up. Latent heat of sensible heat of the air tries to dissipate. That's what I would like to share with you. Dissipation of droplets is generally caused by one or more of the following processes. Number 1, solar radiation. As I said, solar radiation hits the ground gets heated up. Sensible heat is there. Sensible heat will throw the fog. Second thing is droplet setting. As I said, the droplets are there on the upper. So when they are trying to settle down, nobody can stop it. Third one, wind shear or a turbulent mixing. Suppose there is a turbulent mixing. Naturally, fog is a weak phenomenon. It gets dissipated. So changes in the wind. All of a sudden, advective wind is there. With warm advective wind enters from a relative larger. Then fog goes. Overlying cloud layers at night. Sometimes, cloud layers are formed in the night. Natural fog dissipates. These two are just like elder brother and younger brother. So fog and cloud. The next one is the the role of pollutants as far as fog formation is very, very important. Role of pollutants. What is it? Fog is a cloud in contact with the ground where aerosols, including pollutants, concentrations are the highest. Fog is formed basically when aerosols are there. That's it. That's it. Cloud is also formed like that, but it is near the ground. Now, the number, size, and chemical properties of the aerosols and the aerosol particles are key properties in the activation process. The number, size, and chemical properties. Number, size, and chemical properties of the pollutants play an important role with reference to the fog formation. And the influence of pollutants is more in the industrial area. That's what we call it as the smog. FOG, fog, we add S, smoke. Yes, more. So the classification of the fog for your academic interest, there are three types of, not three types, classification of fogs based on A, B, C. A, scale. As far as the scale is concerned, mesoscale fog, synoptic scale fog, large scale fog. Mesoscale fog, synoptic scale fog, large scale fog. Second one, physical process. As I said several times, radiation fog, that's what we call the ground fog, advection fog, evaporation fog, valley and upslope fog. These are all the things as far as the physical process are concerned. And intensity based, this is followed by India Meteorological Department for classification. This classification, intensity based classification is used for types of fog in determining the type of fog. India Meteorological Department takes this type of classification. Which type of classification? Intensity based. What is it? Shallow, medium, dense, very dense. Shallow, medium, dense, very dense. This classification is taken for determining the type of fog for India Meteorological Department. What is meant by shallow? Okay, shallow means visibility up to 500 meters. Moderate means visibility up to 200 meters. Dense means up to 50 meters. Very dense means less than 50 meters distance. So this is what I would like to share with you as far as fog is concerned. In the next class, we'll try to understand what is the mechanism. India Meteorological Department has got a system and a mechanism for fog warnings. That's what we discuss in the next class. Thanking you very much for your very patient hearing.